what we've been working with is the easy form of the circle. Because you can look at it, examine it, and right away say, here's where the center is, and the radius is this, right? So I like to call that the easy form because it's really easy. Circles, I can give it to you in this form. So you've got, well actually this is a jumbled example, but this is kind of what they will look like, okay? And it's going to be up to you to fix it. It's up to you to fix it. Okay? So what we're going to do is we're going to move things around and make it look like what we like. Because looking at this, I don't know where the center is, right? It's not that easy to tell, like it was with the other. So what I'm going to do first, I'm not going to skip any steps because I did it yesterday. If you go, I'm going to simply use my reflective property. Y squared minus x squared plus 8y plus 6x equals 16. Because I like to have the variables on the left side. That's a personal choice for me, okay?
So instead of just rewriting it all, can you erase the 16 equals and put it on the other side?
That's exactly what I did.
I know, but like if we're doing it right here, can we just like erase it?
It's the same property. Your impatience is a little different, which is fine. Okay? Now. Huh? Yeah, it was refractive. What did I say?
Refractive.
Refractor. I also like to have the x first, because remember it's x squared plus y squared type thing, right? X squared plus y squared equals r squared. So I'm going to rewrite this so that my x's are up front. So I've got negative x squared plus 6x minus y squared plus 8y is equal to 16. Now that's just a commutative property that I just used. I used the commutative property to rewrite the order of these things. Nothing fancy yet, huh? Okay. I found you. I'm going to use the, huh? Hey, focus here, broski. Now, what I want to do is that completing the square process that we did last time we met. Remember I introduced, I said I want to make sure I kind of do this. But I don't like the fact that this is a negative in front of the x squared. I really want that to be a positive. So I'm going to use my, I'm going to divide everything by -1. Okay, and I'm going to use my division property of equality to do that. Whatever I do to one side, I'm going to do to the other. So that's going to change all the signs of the top, isn't it? It's going to become a positive x squared minus 6x, positive y squared minus 8y equal to negative 16.
Wait, why would you want to do that?
Because remember when I want to create that perfect square, I really don't want it to be a negative x squared because I'm going to take the square root of it. And if I take the square root of a negative x squared, then I've jumped into the imaginary realm. And I don't want to mess with imaginary numbers.
Okay, so we're always going to do that, right?
Yeah, you always want that to be a positive.
Is there always going to be like negative x squared?
No, sometimes, a lot of times it'll be positive,
So
sometimes
we
it'll be
won't
negative.
always have to.
No, not always.
What if like the x squared is negative and the y squared is positive?
That's a fantastic question. Let's say that you did end up with the x squared and then the y squared was negative. You know, you're no longer working with a circle.
Okay,
You're
so they
working with
both
the-
have
They both have to be positive. And notice they both end up being positive. If they're not, then you're not working with a circle anymore. And that's important to recognize as well. Okay? So, good question. We can go into the details of that later on because there's actually two scenarios. One where your y would be negative, and the other one where the x would be negative. And they're two very different scenarios. So it's important to recognize that.
So what were you talking about when it's not a circle anymore?
If they're subtracted, just a side note because you asked, if you're actually looking at the difference of them, you'd be looking at not what's called a circle, it's actually taking a circle, and instead of joining them by adding them, you're subtracting them. So what you're doing is you're flipping, like cutting here and flipping them out the other way. So you would have this scenario, which is called a hyperbola. So the x squared minus y squared deal is called a hyperbola. And there's two scenarios, like I said, of a hyperbola. They could be doing that, or they could be moving away from each other this way.
Or it could be a basketball court.
No, that's funny.
Yeah, it was.
It was.
It was funny.
It was really funny.
That's good.
Okay, so answer your question there?
Yeah, thank you.
Cool beans. So let's get back to this example because we really haven't done anything fancy yet, have we? Not really. I'm going to start doing that complete the square business. I'm going to color code this. I want to complete the square with this x squared and negative 6x. And it's going to go like this. The square root of x squared is x. What goes in here? What goes in my binomial? It's half of the coefficient, isn't it? So what's half of negative 6? Negative 3. Good. So negative 3. Now, realize that when we multiply this out,
Wait.
Yeah?
Why would you do 3? Because when you square root it, it doesn't equal 6.
the square root of x squared is. You were here last time we met, right?
Yeah.
And I said to you, if I took something like x plus 5 and I multiplied it out, that means x plus 5 times x plus 5. I would go x times x, that's x squared.
Oh, you have to add them together.
And then I would have 5x and another 5x.
What
And finally I would have 25.
Okay.
So I'm just going from there, I'm reversing the process now.
Yeah.
So for the first one I take the square root, but what happens with the middle number that was
You have
10x?
to add together.
I had added, so I had double it.
Okay.
So if I want the middle piece back, instead of doubling, I'm going to have it.
Okay.
Okay? Now, realize how this created a 25 because I had to go 5 times 5, right, at the end? There's what number is created here, that extra number. What's the extra number that's created? 9. Okay? It's negative 3 squared. So I'm actually adding a 9 that was not there. How do I fix this scenario? Add a 9 to the other side of the equation. So I'm going to add 9 over here. Okay? Woo, that wasn't so bad. Now I need to take care of the y part of it.
Wait, so what is that like
Do the
process
same thing
called?
with y.
Go ahead.
What is that process called?
Completing the square.
So you do the same thing with y.
Yeah, and what we're doing is we're completing the square twice. We're completing the square for x, and we're completing the square for y. So now the next portion, let's go ahead and complete that square for y. What's the first variable? Is y, right? What complements that binomial? Negative 4. That adds a little something, doesn't it? What am I adding? 16. Okay? That wasn't there originally. So I'm going to go ahead and balance out my equation by adding it over to the right side.
And those questions.
And then, yeah, those.
Now, if I combine them, that's going to equal 9. And now I can see that this original equation was a circle centered at 3, 4 with a radius of
Wait, why did
Three.
you equal 9?
Oh, that's easy.
Wait, never mind, this is my last one.
That was easy.
And then,
Oh, binomial model? What? You don't have to. Or you can do. Geometry's kind of weird.
it's like 10 times the size of a
Then just do like the stem as a cylinder, and then a sphere for the top.
Okay. Makes sense.
What?
How do you say
It's
Complete. You take off the E, and I.
I'm just curious.
completing. Just do 2 cylinders and then make that.
Yeah.
That was smart. Yesterday? You heard it? You heard it? Yeah, scary. Okay. Questions here? Alrighty. Do you need to see it again? No, I think if you just find center and radius, I'm sure everyone could graph from that point.
So after we finish the equation, then we have to find the center and radius.
Just center and radius, I'd be okay with that.
And then next week, do we have to find the graph it?
What?
Next week, do we have to graph it?
No. You know how to graph a circle. I'm okay. Once you have center and radius, you're fine.
I had Steel help me because I
So
was like,
that's
what do I
when
do?
once we get that like we complete the squares, then we have to find center and radius.
I don't like graphing because I can.
Okay. So I'm gonna go and do a couple things here. I hope I don't lose anybody. This is gonna become x squared plus 2x plus y squared plus 8y equals negative 16.
Wait, did you just skip all the steps?
No, he just did step 2.
I just rearranged it.
Yeah, he did. Yeah, I see.
I like the variables on the left side, right?
Yeah, but that's a negative. How'd you get
Oh, wait, when you cross it over, what did you?
Oh, thank you.
Did you already divide it by negative?
Negative.
Yeah. No, I didn't.
Wait, the 8 is negative.
Okay, so it's on this side, correct? It's on the right side? Where's it now?
On the left side. Yeah, but
So if I change the side it's on.
it's negative. You didn't do that earlier.
Okay, so if I went plus x squared, that becomes 0, doesn't it? What's on this side? X squared. I'm doing a shortcut. You guys have heard the change side, right? That's all I did.
Did you switch the 2x over or just leave it there?
Well, where was the 2x?
On that side?
It was still on the left side.
No, so I'm asking if you switched it this way or the other way.
I didn't move it anywhere.
What about
It's
the
still
negative
there.
y? No,
No, because the negative.
No, because it's still on the right side.
He left it over there. He added everything else but left the negative 16.
Okay, that makes sense. Did you
Yes, yeah.
add anything else about the 16?
I shouldn't have skipped the steps.
I get it. You just added everything.
Do you want me to do them step by step, or is everyone kind of?
No, I need to do it step by step. No, please.
Huh?
Please do it like one more time step by step.
Okay. So, I like my variables on the
Left side.
left side. So I'm going to add x squared here, add x squared over here. Okay, that's 0. So that leaves me with x squared plus 2x equals negative 8y minus y squared minus 16. I want to move this over. I'm going to add y squared to both sides, right?
Why do you want to move that over?
Because I want all my variables on the left side. Okay, that's 0. X squared plus 2x plus y squared equals negative 8y minus 16. If I change that also, right? That's 0. So here's my x squared plus 2x plus y squared plus 8y equals negative 16. Okay? I just did the step by step. That is so nasty.
You tried it?
Oh, no, it was a look.
Ew. I was so confused. I was like, what is he doing?
Oh, drinking the coffee.
I'm trying now.
Okay. Here we go. Tell me when to go. You mind if I skip another steps here?
Nope. I mean, yes, I do.
Yes, I do mind.
Yes, I do.
X plus 1, quantity squared, because I'm completing the square with this, right? That creates a plus 1, so I'm going to plus 1 over here. All right? I'm going to complete the square with the y's. That creates a plus 16, so this is equal to 1. All right.
Because I was, like, you know, the plus 1 plus 16 on the left side? I was kind of overthinking that, saying, like, where is it going? And I was like, okay.
Please don't confuse that plus 16 with me moving sides that it's on, because I'm not. That's a balancing of the equation. That's what I just said. Don't confuse this plus 16 with me moving the side it's on. Remember, that's creating an extra 16, isn't it? So I'm balancing the equation by adding 16 on the right side. Okay? Yeah, don't confuse that with a movement. It's not a movement.
You're balancing the equation. Oh, okay.
That's what. But do you see why it's important to show your proof on the left side now? So if you're trying to walk someone through, they can see. Okay, this is the reason. This is the reason. This is the reason.
Wait, you must write out all
No. But I'm just saying why it's important. Right. If you're writing this for someone, it's important to have that 2-column proof. Yeah.
What are you looking at?
Those are those beads.
The color? What? The lines of the colors? Yeah.
I don't think bunnies will feel that stuff.
Yeah. Man, they even feel bad. In here. It's only 9 o'clock in the morning.
I didn't say anything.
Bad.
I didn't say anything. Jesse, did I say anything?
No.
I was just said I was looking at those headphones.
I'm saying.
I still think too much.
We're good? Again?
Wait, can we do
No.
one more example?
I'm just kidding, guys. Or no. I don't know.
Actually, you want to do the hard one? This one right here?
Yeah.
I guess.
Want to be like two?
Wait, is there?
What are we doing? Like, what's the
Yeah.
That one looks great. Okay. This should read 4x squared minus 8 radical 2x. I'm just using my what's it called? My commutative property to rearrange this because it throws people off for some reason. I don't know why. Minus 12, sorry, not 12, minus 4 minus plus 4 y squared minus 12y is equal to negative 1. Right?
Hold on, let us mark the call. Why did you make it 8 squared? Yeah, why'd you move the x thing?
Does that bother you?
Yes, because it's
Well,
supposed
what-
to be 8x.
Right. No, don't erase it.
It's the same thing.
Oh, okay.
This is saying 8 times x times radical 2. I'm just rearranging the order and multiplying. I'm going to go 8 times radical 2 times x.
it make any difference?
Wait, is that an X or a Y?
Does that make a difference on how I write it?
What about 4 times 3?
I guess no, I could be 3 times.
No, that's called the commutative property of multiplication. So anytime I'm multiplying things, I can multiply in any order I want, and it's still the same. Okay? All right. Awesome. Awesome. Here we go. You're lost? Where? How? What?
Cool. Where'd you get away?
How? Where? Tell me where. I rewrote it.
Were you sleeping?
Here is 4x squared. This is the negative 8x radical 2, which we just finished. We can write in any order we want. Here is 4y squared right there, exactly how it, right? And then here's the negative 12y right there. And all I did was kick 1 to the other side, so it's a negative 1 now.
You just rearranged it.
I get it.
Why is it
Can I rearrange the way it looks? What property lets me do that? The commutative property of addition. Are we good, Mike? Mikey Mike? And the funky bunch?
How did you get -1? Really?
Well, it was positive here. I moved it to the other side of the equation. So it becomes a negative. Change side, change sign.
Oh, yeah.
Thank you. Any other questions? Thanks for saying something, OTT. Stop doing that, Shelby. Stop and focus. All right, cool. Now, I don't want this to be a 4x squared. I want it to be just x squared, right? So I have to divide everything by 4, because if I want to do it to that, got to do it to everything. That makes this x squared minus 2 radical 2 times x plus y squared minus 3y equals -1/4. And I just use my division property of equality. 7.
Where? That's
4.
Oh, that's like a 4.
Wait, where's the 7? What are you looking
That looks like a 4.
This 4?
at? That doesn't even look like a 7.
I see where nice that it looks like 7.
Yeah, I can see it too.
Just the. I guess it's backwards. No, not this one.
No, it looked like a 7. My little. Whoa! What did I just do?
Oh.
Go back.
Okay, there it is. You don't really put that function.
¿Qué onda?
And what if the y squared and x squared didn't have the same number? Then is that the same thing like it would be in a circle?
Yeah.
Wait, why didn't you divide the 2 by 2?
I divided everything by.
No,
No,
the radical
2. You divided the 8, but not the 200.
Because I divided the quantity
Okay.
by 2. Here. 8 radical 2 over 4. Okay. You're only going to divide the whole piece there. Okay. I wasn't writing a 4 at all.
Like 2 of the 4. It looks really cool though. It's like a fancy.
I was writing a 2, so I just went 4. I had to change the way I write my 4s. My 4s used to be like that.
Yeah, those are ugly. Just kidding.
Oh.
No, like now.
That's how I
Not yours.
Why'd you change it?
People were confusing it with other symbols like the plus symbol or something. Yeah.
Oh, like the and symbol?
Yeah. Or my 4s. Sorry. Yeah. My Y's, you know how many people do their Y's where it's 2 strokes like that? I can't do that anymore either.
Why always make it?
Because when you write Y's fast enough, they start to look like, so people were like, so now, I don't know if you notice, I write my Y's like this now.
I used to write my Y's like that. I write my Y's like that.
People be like, is that an X or a Y? Okay, back to here. Back to here. We're ready for the complete the square process. So, here we go. Cut it right there. There's the x's. So, the square root of x squared is x. Half of negative 2 radical 2 is simply negative radical 2. By squaring that, I'm adding 2 to the equation. Correct? You don't see that one? That's okay. By taking the square root of negative 2 and squaring it, I'm taking negative radical 2 times negative radical 2. Negative negative makes positive, and then that becomes the square root of 4, and the square root of 4 is simply 2.
Oh, okay. Now,
Wow.
Okay?
Did you just?
That's good stuff.
math.
Math! Yeah! All right, cool. So, back here now? Oh, thank you, thank you. I missed it. I didn't add it to the other side, did I? Ah, yeah. Okay. Now let's take care of the y's. So we're going to add y. Half of 3, or negative 3 is negative 3 halves.
Wait, what?
I'm not messing with that. I ain't trying to write that as 1.5.
Wait, how did you get 3 halves?
Well, I had to divide 3 by 2
Wait, why?
because that's what goes in there. It's half of the term, right? So that adds an extra 9 quarters to my situation. So I add 9 quarters here. You see why I love fractions? Try doing that with a decimal.
I don't get it.
What's the extra? What's the extra?
Why do we have to?
We have to complete the square, OTT. So what's the extra part that gets added by completing this square? It's not 7. Half of negative 3 goes in there. Where does this radical 2 come from? Half of that. So we're completing square for y now. We need half of that y value in there. Yeah? If this was a 4, what would go in my binomial? How'd you do that? Half. So it's a negative 3. What goes in there? There it is. Okay? Now what's the extra part that gets added to my equation? It's the negative 3 half squared, isn't it? Which is 9 quarters. Yeah, Fufu?
Can you go to slide 7?
Can I go to slide 7?
Yeah, that one. Okay, so when you, it's 2, right?
Yeah.
But when does that 2 on the outside come in?
That's squared, bro. This right here, I wrote it ugly, I'm sorry. That is the radical 2 quantity squared. That means that times itself twice, right? This is telling me to do this right here.
Yeah.
So then I can do the math. What's a negative times a negative? Positive. The square root of 2 times the square root of 2 is the square root of 4. And what is the square root of 4? 2. Or if it pleases you, you could say, it's the square root of radical 2 squared, which kind of undoes the at, and you just left the 2 inside. Is that what you're going at? All right, cool. So we're here. All right, now I like these fractions. 9 minus 1 is 8. 8 divided by 2 is 2. And 2 plus that 2 gives me 4.
8 divided by 4 is 2. You said 8 divided by 2 is 4.
My bad. If I said that, I'm sorry. 8 minus 1, sorry. I already have the numbers in my head. 9 minus 1 is 8. 8 divided by 4 is 2. Plus the 2 here is 4.
Oh my.
What's going on? What are the one?
Like you added it to the left side.
Oh,
2, 2. They are. They're part of this now. Welcome back to class. Okay. There it is. Don't try to get fancy with it. Again?
Wait, so would would it be x minus?
Hey, just so you know, these aren't the ones from the homework. There's a whole different sheet on them. Because people are like, yeah, let's get them to do all of our homework. No.
Okay, this is like random, but can you say like again, like really, really fast, like after again, like that?
Again.
Yeah. I find it so funny.
Can you just explain to me that part again?
What happened?
Just that.
You want to see all of it?
Um,
Oh, it is all of it right there. Boom.
yeah, no, can you explain this to me again? Okay, I get how you got, like, I get how you divided 4, and then.
Okay. Here I just completed the square. This is me completing the square. So I took the square root of that. Half of this is that. If I square that, that gives me 2. So I throw 2 over there. Okay. Then I'm going to complete the square here with y squared minus 3y. Half of that is negative 3 halves. Square that, that's the extra stuff. I throw it over there as well. Then I just clean it up. It becomes 4.
I still don't get that part.
What part?
That red part right there. Can you solve that out for me? Like that x minus.
Yeah. Okay, so when I'm going to complete the square, it's the square root of this, isn't it? That's x. And what goes in here? It goes half of this coefficient. Half of the coefficient?
Oh no, I get it. I just don't know why.
You don't know how to half it? Negative 2 radical 2 divided by 2. The 2's make 1. So I've got negative radical 2 in there. We're good?
Yeah.
Okay. Alright, are we done? Or are we doing another? Okay. That way I can end this.